So, good morning, everyone. I would like to introduce myself. I'm Professor Klaris Fogaidis from Frederick University. I'm also the founder of UFIA Tech, a spin-off at Frederick University, and our main field with our spin-off UFIA concerns the assessment of smart buildings, of the smartness of buildings. Today, I will be presenting the Smart Readiness Indicator. That is a new scheme that has been developed by the European Commission and that concerns the assessment of the smartness of buildings. So the SRI was first introduced in 2018 with the Directive 2018-844 of the European Union for the energy efficiency of buildings, and it introduces for the first time a scheme for assessing the smartness of buildings. Currently, this scheme is voluntary, it's not mandatory, but according to the developments and to the recast of the directive, we expect that from 2026, this scheme will be mandatory for buildings that have an installed capacity for heating which exceeds 290 kilowatts. And as of today, with the recast of 2018, we have the obligation of including building automation and control systems in such buildings, that is buildings which have an installed capacity of over 290 kilowatts. So today's presentation has its meaning because it also describes some of the developments that we expect to have in the field of smart buildings in Cyprus in the following years. So if we would like to define what is a smart building, we see here the definition that we have for smart buildings that is given by the European Commission. In simple words, a smart building is a building which has the ability to understand the conditions within the building, to interpret the needs of the user, and to adapt the operation of the building to the needs of the user. At the same time, a smart building sets also some other criteria which involve the energy efficiency. That is, a smart building regulates the performance, monitors and regulates the performance of a building with the purpose to reduce the energy efficiency. And the European Commission has set a third pillar for smart buildings, and that is their ability to interact with smart grids and microgrids. So based on these three principles, that is the ability of a building to adapt to the needs of the user, the ability of a building to regulate and control the HVAC system of the building towards reducing the energy consumption of the building, and the integrability of a building with smart grids and microgrids. These three parameters constitute the framework under which a smart building operates. And the methodology that we are going to introduce satisfies all these three parameters. Now, what you can understand by our introduction is that what we discuss here concerns building automation and control systems, which are addressed not only for HVAC systems, but also for other appliances of the building or even for lighting. We will see later in detail in the presentation how the different domains of energy consumption are handled under SRI and what are the criteria based on which we assess the performance, the smartness performance of these domains. Now, we see the developments in the field of the past 5 years. We see them in this slide. The scheme was firstly adopted in May 2018. By 2020, we had the delegated acts, that is the regulations, the European regulations that define the actual performance of the SRI and give a specific content to the SRI. And since 2021, we have the implementation of test phases in member states for adapting the SRI. In Cyprus, we also attempt to introduce a test phase. We have signed an MOU, that is our university, with some other affiliations in Cyprus who have interest in the field. And we are in negotiation with the Ministry of Energy and with the Energy Service to implement this test phase free of charge in order to be able to adapt this scheme for Cyprus as well. So the conditions with the member states are shown in this slide. As you can see, we have initiated the test phases, and currently these test phases are implemented in member states. As of today, we have 6 member states which implement test phases. A 7th one was added a few days ago, that is the Czech Republic, and we aim to have Cyprus as the 8th member state in which a testing phase for the SRI will be implemented. Now, to be more specific about the SRI, What does the ASHARE include? The ASHARE includes some aspects which are required and some aspects which are optional. What are the required aspects of the ASHARE? The first one is, of course, the framework which was described in the previous slide. That is the fact that the ASHARE assesses domains, services, and functionalities which cover the three fields, the three criteria that we have already mentioned: the human comfort, the reduction of the energy consumption in buildings, and the ability of a building to interact with smart grids. So these three are core elements of the ASHARE methodology, and these are the so-called three key functionalities. Now, based on these three key functionalities, the ASHARE also has 7 impact categories, which are those. We see them here. These categories concern the energy efficiency, the maintenance of the building equipment, the human comfort, the I will need to wear my glasses, sorry. So, the convenience, the health and well-being, and of course, information to occupants. And the 7th impact criterion for the ASHARE is the energy flexibility and storage. As you can see in this slide, these 7 impact criteria are classified in 3 levels. And the 3 levels are the 3 parameters that we have already mentioned. That is the energy efficiency. The first 2 criteria, impact criteria, are targeted for the energy efficiency. The human comfort, that is the 2nd class of criteria, are targeted for the human comfort. And the smart grids, that is the energy flexibility and storage, is targeted for the smart grids. And the other core element of the ASHARE methodology concerns the domains, that is the technical domains which we assess for the ASHARE. That is the heating, the cooling, the domestic hot water, ventilation, lighting, dynamic building envelope. This refers to the ability of the building to allow natural lighting or not with shades, electricity, electric vehicles, monitoring and control. So these are the 9 domains under which we have the different functionalities that we assess to define what is the smartness of the building. And the last required domain concerns the rating. So the ASHARE ends up in a rating that defines different classes of smartness. So the ASHARE, the final result of the ASHARE, is a smartness class for the building. So these elements demonstrated are the core elements, the obligatory elements of the ASHARE. What are the optional features, and which are the features which are expected to be defined by the member states? These features are, of course, the service catalog. That is, each member state has the ability to revise and propose its own service catalog. There is currently a service catalog which consists of over 60 services, which are split to the 9 different domains defined. And these are related, for example, for heating, for the generation of heating, the transmission of heating, the distribution of heating in space. For the lighting, for example, these functionalities, domains are concern the control of lighting and the regulation of lighting in the building, and so forth. So the member states have the ability to revise this catalog, this ASHARE catalog, and this is one of the exercises that it is implemented by the national testing phases. The other aspect which can be revised by the member states are the weighting factors. So for each impact category or for each domain, we are allowed to have different weighting factors. And we will see later in this presentation that the Commission has classified the European continent in 5 different clusters of countries in which different weather conditions dominate. And with this information, we can also adapt the weighting factors of the methodology. And other aspects such as connectivity, interoperability, inclusiveness, cybersecurity, because you realize that we refer to building automation and control systems, we refer to big data management, IoT, data transfer, information and so forth, so these aspects can be regulated locally by the member states.
Έχουμε 5 λεπτά.
Now, what concerns the impact criteria, you see them here, we have already referred to them, and the domains, which were already presented. And this is how we link the different impact criteria to the 3 pillars that we referred for the methodology. And of course, for each service, we have a different rating, which is based on the 7 impact criteria that we have mentioned. And we see here the whole rationale of the scheme, starting from the criteria, going down to the scores, to the domains, to the services, and to the scoring of each service for each domain. The final result of the SRI, we see it in this slide. We have actually a matrix which delivers the different domains and for the different impact categories a specific score. And out of that, we have a weighted score which delivers the smartness assessment of the building. As I said, we have different geographic clusters in which we have different weighting factors. And we see here the 5 clusters and the weighting factors for the different domains for residential and non-residential buildings. And as said, the member states are flexible to change, to revise these weighting criteria, and these are the clusters that we have across Europe. Now, to proceed with a worked example, before we do that, at this point we have 7 tools which are approved by the European Commission. This is a slide that comes from the webpage of the European Commission. We have 7 approved tools that may be used for the calculation of the SRI. One of these tools, the Smart Ready Go, is a tool of UFIA Tech, our spin-off at Frederick University. This is an approved tool by the European Commission for the calculation of the SRI. Now we demonstrate here an example, a worked example with the calculation of the SRI. We did that for our new wing building at Frederick University. Here are some general information concerning the building. It's a mixed-use building. You see here the energy consumption and some other information. These are the drawings, the 3D drawings of the building. And this is the result of the SRI for the specific building. You see that the SRI, the score per se is not of that importance. What is important here to see and to document are the different, is the way that the SRI is presented. That is, it shows the smartness of the different services on the right side, as well as the smartness of the different impact categories on the left side. Now, to conclude, why do we need smarter buildings and what is the link between smarter buildings and our field as HVAC engineers? Apparently, smarter buildings may lead to energy efficiency, to the reduction of the energy consumption. And that is why, since we are in a transition, we move to the era of smart cities and smart buildings, we aim to set some rules to make the definition of smartness objective and not subjective, to have that as a specific framework and a specific methodology with which we identify what we describe as a smart building. And apparently the advantages that we expect to have from the enhancement of the smartness of the buildings will also support all the initiatives that are taken in the field of smart grids and microgrids, and will allow the further penetration of the renewables and the transition towards a neutral, a carbon neutral era. And of course, in the field of operation and maintenance, the smartness, enhancement of the smartness of buildings will also give better conditions for maintenance and of course for the operation of the HVAC equipment. I would like to thank you for your attention, and I'm at your disposal for any questions. Thank you.